Right.
Number patterns, guys. Who did the number patterns chapter? I saw quite a couple of you guys do it. That's fantastic. Today's going to be super easy then. We'll get through it quite quickly and hopefully it's quite fun. I quite enjoy number patterns because it requires a little bit more insight, a little bit less learning, and again goes back to the very first thing I said in the first lesson, trying to make things as easy as possible for yourself. So as long as we can understand the basic concepts here, it's very easy to apply that to all the general examples. So with that in mind, I want to just check out these couple of examples. The very first one, 1, 3, 5, 7, 9. What's next, Jackie?
It's 11.
It's 11. Easy. So you guys have pretty much got the stuff down already, okay? It's that simple. The problem comes when I want to say, well, what if for the first one, I want to know the 914th number in the number pattern?
Tn
Yeah.
equals to 2n plus 1.
Okay. How did you get that?
I went to school, Nick.
What is Tn actually talking about? Yeah.
It's the term, okay, and then how many number the term will be in.
Fantastic. Okay. So just quickly, what is a term, Rex? Give it the bash.
A term is the way something is described, in a way.
Terms and conditions in a contract, right?
Yes.
Since it's on sequences and all,
Yes.
a term is actually the digit we're looking for.
Fantastic, alright, that's exactly what we're talking about, okay? We have a sequence here, which is a number of numbers that follow each other, okay? The term is a specific one of those numbers. So that is a term, that is a term, that is a term. That is a term, good. We give, it is also 7, but it's one of the terms in that sequence, okay? Play along with me, Diesel. Guys, what we do is we give each of those terms specific numbers so that we know which number we are referring to. So, is this the first term in the sequence? Yes. It is. What I call it is T1. Good. What is this one?
T2.
Good.
T3.
Good.
T4. T5.
T5. Fantastic. So, what is the 913th term?
T913.
T913. What if we don't know the number of the term?
We'll work it out.
Nth term.
We call it an n. Because what is an n? It could be?
Anything.
It could be anything. The nth term is telling us we don't know what the specific term is, so we're just using n as a placeholder for any of the terms. So what we want to try and work out then is in terms of n, how can we solve for any single one of those numbers in the sequence? Is that possible or not?
It is.
It is possible. Good. Diesel, how's it possible?
Explaining that is really tough.
Okay, fantastic. Okay. So what we got is this concept of Tn, which will give us any one of those terms. So we want to try and work out a rule to get any one of the terms in the first one, and then you guys are going to go and do parts 2 and 3 quickly because you'll see that it's not too bad. So we want to try and get ourselves a rule. So the very first thing that we try and do is work on what we know. You guys have already told me how we can get from this term, T5, to that term, which is T6. What did you do?
You plus 2.
You plus 2. So how do you get from T1 to T2?
Plus 2.
T2 to T3?
Plus 2.
T3 to T4?
Because that's vertical.
Fantastic, okay? There is a constant difference between every single term in the sequence. So if I had T912, how would I get to T913, Chanli?
You have to plus 2.
You have to plus 2. That's simple. Okay, fantastic. You don't have to get so nervous. That's exactly the right answer, okay? And it's that simple. So once we realize the fact that these specific sequence, and we're going to call it a name now, which is arithmetic sequence. Heard that name before or not?
Yes.
Okay? No, some guys haven't, some guys had. All it is, it's a name for it. So we're calling all sequences of this nature arithmetic sequences. And the nature that we're looking for is the fact that there's always a constant difference between each of these successive terms. Okay, a lot of terminology in that sentence. Did you guys understand it?
Oh, so there's a -5 in the second row.
Good, okay. Arithmetic sequence means that for the sequence, each term has a constant difference between the terms on either side of it. That's all we say. That's an arithmetic sequence. So all 3 of these are arithmetic sequences because they've got constant differences. Cool.
Okay, never mind.
Now, what I want to try and do is use this idea that we've just got from using this constant difference to try and draw up a formula to figure out how we can work out each of these numbers. So if I've got, this is sitting as 1. This is term 1, and I want to get to 2.
Go to plus 2.
Plus
I could plus 1. Good. Plussing 1 is a fantastic option.
Or
So
you can minus 3. Okay, minus 1 from 3. You can also do
you
that.
could minus 1 from 3. How do we get to 3?
You plus 2.
You plus 2. But that is then 3 minus 3 plus 2. Plus 3 minus 2, you then get into your plus 1 again.
Yes.
So you just said the same thing, just in a bit more roundabout way.
Yes.
Okay. What I'm just going to do is write up a little bit of a table here.
What is the int stand for?
Good question. I'll tell you now.
It's 1, 3, 5, 7.
Okay.
22.
22.
No, it's
It's just a
a thing.
Rex is going to tell us 22.
Okay.
Okay. The n is telling us which specific term we're talking about. So, what's so funny?
The position. I'm sorry.
Okay.
Shame this order.
Yeah.
Can you repeat that?
We've got, so n is talking about the specific position in the sequence. Okay. So what position is this number?
So 1.
It is term 1, so it's in position 1. This one is term 2, so it's in position 2. This one is term
3.
It's in position 3.
Yes.
Okay, term
4.
good, in position 4. Fantastic.
22 would be.
So what we want to try and work out is how can we link the n to the number that we got here. Okay, and you guys have already told me that these things have a difference of 2 between them. So we're trying to work out how can we use the fact that there's a difference of 2 between each of these terms to get from the top, the top numbers to the bottom numbers. We've already got a suggestion from Jackie that says to get from term 1 to 1, what can we do?
Plus 3 minus 2.
Okay, well, I think we were looking at different numbers. But how can we get from 1 to 1?
1 plus 0.
1 plus 0 does it. Good. Plus 0 is a good option, sorry. Does 2 plus 0 give us 3?
No.
No. So that does not work. Because remember, we want to get this solution that works for every single one of these n's to get us to every single one of the tn's. Okay? And I'm going to leave you guys a hint. We want to use somehow this number of 2.
Okay.
We want to use the fact that I've got this 2 times difference in every single one.
I gave you that formula.
You did. So how did you get to it?
How did I get to the formula? Well, you have 1. The difference is 2. 1 times 2 is... 2 times 1.
Good. 2 times 1 is 2.
Yes.
Good.
And
So then I've got 2, but how do I get back to 1 now?
minus 1.
Fantastic. So we've got an option of 2 times n minus 1.
Yes.
Okay.
And then 2 times 2.
Can I ask you, where does this 2 come from?
It's the difference.
It is the difference there.
Yes.
Fantastic. Okay. And that is essentially exactly what we're going to be doing now. Ashley, can you tell me what is 2 times 2? Minus 1?
It's 3.
Does that work? Jackie, what is 2 times 3?
2 is 6.
Minus 1?
5.
Do we get to our number?
Yes.
Fantastic. What is 2 times 4?
It's 8. Minus
Good.
1 is 7.
Fantastic. So what you guys have done is you've just solved Tn.
You guys. My credits.
Lisa, well done. You've solved with the help of everybody.
What?
Okay, we're all discussing it. You've just solved Tn, how to get to the nth term from the number n. The rule that you used was you took the constant difference 2, you found the first term, you times it by 2 because that was the bit of insight from Lisa, and you said, well, what do I have to then subtract from this or add to it to get to the 1?
So would the answer 913 times minus 1?
Be the Tn is equal to,
1825.
so T913 is equal to
1825.
2, 5. So there's our answer. Okay. Backtrack a little bit. You guys have all now learned a formula for exactly how to do this. Kind of, some of you. These are might have. Okay? What is that formula?
Tn equals to 2n minus 1.
Okay, that's the specific one. What we want to try and do is elaborate on that formula to get the formula for any arithmetic sequence, so we can get the answer for every time. Actually, no.
Tn is equals to A
plus open bracket n minus 1 d.
Okay, cool. So you've learned this formula. This is the textbook way to do it. Absolutely fine. What is the d, Ashley? Okay, thanks, Liesel. Let's grow up at least half our age and then move on with it. What does the d stand for?
The common difference.
The common difference. Good. The common difference in this case is
2.
Okay, that's the size of Liesel. A. What is A?
First term.
A is the first term. In this case, what's the first term?
It's 1.
It's 1. Fantastic. Okay. So you could take the textbook approach, learn the formula, apply it. A is 1 plus n minus 1 would give us times d. So it's 2n minus 2, and we've got our formula that Lee's already worked out. Okay. What I want to rather do is work with it this way because it shows a little bit more insight into the problem. We said we know the constant difference is 2. If I times 2 by the n, I can actually often get to a number and then work back to the actual Tn that I need. Does that kind of make sense? We've got two different approaches to doing this problem. So let's try it here. You've already told me that the difference is what?
4. No, that's 5.
4. So how do I get from 13 to 9?
You're minus 4.
I'm minus 4. So the difference is what?
Minus 4.
Minus 4. Fantastic. This is T1 here. So 1 times minus 4 gives us what?
It's 4.
1 times minus 4.
Minus 4.
Gives us minus 4. Thank you, Shanley. Cool. So in this case, let's just get a new page. T1 is equal to 13 is equal to 1 because of T1 is going into the n space times minus 4. But is that true? Is 13 equal to minus 4? What do I have to add to minus 4 to get 13?
No, wait, I'm joking.
Sorry, what was the question?
What do I have to add to minus 4 to get 13?
Don't you have to add 9?
Minus 4 plus 9 gives us
Oh, wait, my bad.
5.
12.
He has to
Plus
add
5. Plus 2.
17.
Thank you, Liesel. 1 times minus 4 is minus 4, plus 17 is 13. That is true. Let's see if this works. What is T2?
9.
Good. Is equal to 2 times minus 4, and our rule is plus 17. Is that true?
Yeah, 14.
No.
2 times minus 4 is?
8.
Minus
Minus 8. Remember, you're carrying the minus, okay?
Oh, so you can't
Minus
get
8
plus
plus
6.
17 is?
9.
9. And you got the answer. So what is Tn?
Tn is that? No, it's actually plus 17.
Is that not? Oh,
Sorry?
That was really good.